Okay, good morning or good afternoon or good evening. I'm here to do an example problem on communication system capacity. And what we're doing is we're looking at the equations for system capacity. And there are two of them, and I'm going to go ahead and just write those equations down here as a way to start. And we first have Nyquist, and that applies to the noiseless channel, and it says that the maximum bit rate let's see if I can write neatly enough that you can read it, that the maximum bit rate is equal to twice the bandwidth times the log 2 of the number of levels, signal levels, that we're sending. And then for the noisy channel, Shannon gave us the fundamental limit, which says that the bit rate is limited by the bandwidth, BW, times the log base 2 of 1 plus the SNR, where the SNR is given as a ratio. Okay, so those are the two equations I'm going to be using and looking at to do these problems. And so the first one here says consider a noiseless channel with a bandwidth of 10 megahertz. So we're given the bandwidth, and we're given a noiseless channel, and so we're going to use the Nyquist equation. Suppose the transmitted digital signal has just two signal levels. Well, there's our L value. What is the maximum data rate for this channel? So I'm going to write BW is equal to 10 megahertz, or 10 e to the 6th hertz. And I'm going to write L is equal to 2, and I'm going to say noiseless. And so we're going to use Nyquist. And it's asking for what is the maximum data rate, so I'm just going to plug into the Nyquist equation. The maximum data rate is twice the bandwidth times log base 2 of L, which is twice. You know what, I'm going to go ahead and keep it as a 10 meg. I'll write 10 e to the 6th. I'll go ahead and plug it in like that. Log base 2 of 2. Log base 2 of 2 is just 1. And so this is 20 e to the 6th, or 20 megabits per second. If I can write the whole number down, 20 megabits per second. That's why you have to check your work. It's too easy to write these things. Okay, so 20 megabits per second is the maximum data rate for that channel. Now we're going to move to L equals 4. What's the maximum data rate? Well, RB is now 2 times 10 e to the 6th times the log base 2 of 4, which is 2. And so this gives us 4 times 10, or 40 e to the 6th, or 40 megabits per second. This is a bit rate, RB, so when we get a number like 40E6, we're going to give that units of bits per second, and the E6 gives us a mega, and so 40 megabits per second. If we move to 256 signal levels, now L is 256. Here L was 4. And we're just going to plug in again 10 e to the 6th, log base 2 this time of 256. And that is 8, because 2 to the 8th is 256. And so now we have 2 times 8 times 10, or 16 times 10s, or 160 times 10 to the 6th, or 160 megabits per second. Okay, so that's how you do this problem, and I hope that helps.